Vanakkam. Welcome to this video on biomechanics. We have been looking at biomechanics of hip. We looked at the anatomy of the hip joint, the movements that are possible in the hip joint, and in the next video we also looked at the muscles that support and that are responsible for movements at the hip joint. In this video, we will be looking at a numerical problem, a simple problem involving the hip joint. This is static analysis of the hip joint. Let us read this problem. Consider a situation where a person is standing stationary on the right leg. That is, this person is standing only on one leg, single leg stance. Okay. For the purpose of this problem, let us assume this is true. Figure A shows the forces that are acting on the leg. Capital F suffix M is the net force exerted by the abductor muscles, is the force that is exerted by the abductor muscles. Okay. Capital F suffix J is the joint reaction force acting on the femur, is the force that is exerted by the pelvis on the femur. W1 is the weight of the leg that is acting from a point B that is shown there. W1 is the weight of the leg, and W is the ground reaction force. W is the ground reaction force. This is the force due to the mass of the person, right? This is the weight of the body. Theta is the angle between the horizontal and line of action of Fm. Theta is the angle between the horizontal and the line of action of the muscle force Fm. Okay. Figure B that shows a simple mechanical model of this leg with the corresponding parameters to define the geometry of this problem. O is a point along the instantaneous axis of rotation of the hip joint. Okay. O is this point. This is the point that is along the instantaneous axis of rotation of the hip joint. Point A is the point where the muscles are attached to the femur, where the hip abductor muscles are attached to the femur. Okay. Point B is the center of gravity of the leg, that is where the weight of the leg is acting from. Okay. It is the CG of the leg. And point C is where the ground reaction force is acting. The corresponding moment arms are all given. Okay. The corresponding moment arms are given. Question is, draw the free body diagram for the leg that is shown. Determine the force exerted by the hip abductor muscle, that is, find Fm. Determine the joint reaction force at the hip, that is, find Fj. And this is a problem that we have sourced from a textbook, with due thanks to the authors. Now, let us start with the free body diagram. This is a free body diagram of simple free body diagram of the situation. Okay. Fm is acting at this point A, and Fj is acting at that point O. W1 is acting at this point B, and W is acting at this point C, capital A, B, C. What are the knowns in this? What is known or given? Well, what is known is the distances A, B, etc. are known. W1 is known, W is known, W1 is known, W is known, the distances A, B, C are all known. So, that is A, that is B, and this whole distance is, these things are, and for convenience the angle that the line AO makes with the horizontal, that angle is given to be alpha and that angle is given to be beta. Okay, that is known, and Fm itself is acting at an angle of theta to the horizontal, that is also known. Okay. Now, can I resolve Fm in terms of theta? So, what is known is small a, b, c, w1, w are all known unknowns to find. What is that to find? Fm and Fj. This is what we need to find. Can I write out Fm in terms of its components? The answer is yes, I can do that because theta is given. Yeah, theta is also known, by the way, theta is also known. Yes. So, Fmx that is Fm, is it not? I am interested in knowing that because this is Fmx and that is Fmy, and Fmx then is Fm cos theta and Fmy is Fm sin theta. Okay. Now, if I want to write out the equation of moment about say the point O, what would be the various forces and the corresponding moment arms that cause this, right. Now, let us write out the various forces, the corresponding moment arms, and whether that is a clockwise or counterclockwise moment for each of the force, right. Fmx, force, moment arm, direction. It is useful to come up with a table like that for your own understanding and clarity. Okay. Fmx, the corresponding moment arm is, you see Fmx is acting in this direction, is it not? That corresponding moment arm is Ay, corresponding moment arm is Ay, that is that distance, is it not? That distance Ay, okay. That corresponding moment arm is Ay, and that will be causing a counterclockwise moment, is it not? Counterclockwise, because this is important to determine the SIGN sign of this. Okay. Then Fmy, the corresponding moment arm is Ax. So, that is the distance for the y component of the force, that is where the y component of the muscle force is acting along. So, that particular distance is this, because I am taking the moment about this point O, and that will cause, because this will be the force that will cause a clockwise moment. So, the two components of the muscle force cause moments in two different directions, something to keep in mind. Okay. W1, W1 is acting from that point, is it not? From that point. it is a point that is located, that is not Bx, right, because I am interested in finding moment about this point O. Remember, moment I can take about any point I want in this system. I am interested, the way I have drawn, that is O actually technically. So, this is the distance that I am interested in finding out. That distance is Bx minus Ax. Okay, it is a very small distance. Okay, that is Bx minus Ax. Remember, it is not Bx alone, it is Bx minus Ax. Why? Because I am taking moment about O and I am only interested in knowing the perpendicular distance with respect to the point O, right, is what I am interested in finding out. That is Bx minus Ax. That will actually cause a clockwise movement, is it not? That will actually cause a clockwise movement. Then what? Then W. W is acting at that point C and that distance is Cx minus Ax, like that. And that force is acting in this direction, so it will be causing a counterclockwise movement. Note, I do not know what is Ax, Bx, Ay, By is. I only know A and B. The corresponding alphas and betas are given. Now, not only the forces have components, the moment arms also have components. So, I need to write out Ax, Ay, Bx, By in terms of alpha and beta respectively. This is something that I need to do. Why is that? Because the moment arms have components, I need to do that. So, the component Ax, what is Ax? Ax is, that is Ax, is it not? That is, we said, if this is A, right, that is the distance between this. The corresponding angle is alpha, we said, and I am interested in finding out what is that distance, that is Ax for me. That is, if I know this to be A, this is the distance that I need to know, and I am interested in knowing what this value is. What is that? That is the adjacent side of this right triangle with angle alpha, right. That would be A cos alpha, is it not? Check this, please spend a few minutes and go back to your resolution of vectors and forces and check whether I am correct. Okay, I know that I am correct, but please do check. Okay, Ay likewise is that distance, that distance. That is the opposite side to angle alpha in the right triangle, this right triangle. Okay, that is A sin alpha. Cx is what? That is C cos beta, because I only need Ay, Ax, Bx, Ax and Cx. I do not need By and Cy. So, I need to know Cx. Cx is C cos beta and Bx is B cos beta. Okay, check this. Now I am writing out the equation sigma m is equal to 0, counterclockwise is considered positive. That is the equation I am writing. What would that be? That would be W into Cx minus Ax plus, I am writing out the counterclockwise components first, plus Fmx into Ay, okay, minus Fmy into Ax minus W1 into Bx minus Ax. Is there anything else that causes a moment? No, the whole thing is 0. Substitute for values of Fmx and Fmy in this equation. Okay. That is, if I call Fmx and Fmy as 1 and 2, sub 1 and substitute equation 1 and equation 2 in this equation, which I am calling as 3, and also substitute for values of Ax, Ay, Bx, Cx in your equation 3. Substitute all these values Fmx, Fmy, Ax, Ay, Bx, Cx, everything I am substituting in one go in this equation 3. When I do that, what will I get? I will get something that is going to look very scary. That is okay. Okay. This is where bookkeeping helps. So, you need to know the variables that you are working with. You need to know what are all the variables that I am working with. I am able to do this because I am having a calm mind and I am not having any exam pressure. If you practice doing this several times, you will also develop the calm mind that you can use in your exam. Critical. Because in the exam, if you miss one of these variables, you will get the wrong answer. And if you get the wrong answer, you will lose most of the grade, most of the points for that question. It is very crucial that you develop the discipline of bookkeeping. What are all the variables that I am working with? What are the corresponding momentums? What is the direction of the moment? Because now I am going to directly substitute in one equation all these variables. It is likely that you will make a mistake if you do not keep your books clean, right? Something to keep in mind, simple tip, pro tip. Okay. If I substitute, I will get W times Cx minus Ax. What is Cx? Cx is C cos beta minus Ax is A cos alpha. Remember that I told that we are going to get something that is going to look scary, right? That plus Fmx Ay. What is Fmx? Fmx is Fm cos theta. Ay is A sin alpha times A sin alpha. Why am I having this theta and alpha? I am having an x component of force and a y component of the momentum. That is why I am having an alpha and a theta. I am having a sinusoid and I am having a cosine. I am having a sine of alpha and I am having a cosine of theta. All these things. It looks scary. This is because you are having a y component of the momentum that is multiplying, that is working with an x component of the force. These are two, this is how it will work, right? Because these are perpendicular, this will always be perpendicular. Because these are components, you will always have an alpha and theta coming into the picture, which is why bookkeeping is absolutely crucial in these kind of problems. Otherwise, you will get lost, very easy to make mistakes. Please keep your books clean and practice this problem and problems like this many times before the exam, very crucial. Okay. Fm cos theta times A sin alpha, then what else? Fmy times Ax minus Fmy times Ax, but what is Fmy? Fmy is Fm sin theta times Ax. What is Ax? Ax is A cos alpha. Are we done? The answer is no. There is one more thing, minus W1 times Bx minus Ax, minus W1 times Bx is B cos beta minus Ax, Ax is A cos alpha. Okay. This whole thing is 0. In this, the only unknown in this equation, the only unknown is Fm, everything else is known. I know W, I know C, I know beta, I know alpha, I know theta, I know A, I know B. I know everything. I know W1 and I know W. So, I know everything except Fm, and Fm is what I need to find because that is an unknown. Fm is what I need to find. I know everything else. Theta is known, alpha is known, beta is known, everything is known. Now, after some algebra, I request you to please do this algebra. After some simplification, isolate Fm, separate Fm from the rest of the equation and find the expression for Fm in terms of all of this. That would be, what would that be? That would be W1 times B cos beta minus A cos alpha minus W times C cos beta minus A cos alpha, the whole thing divided by A times cos alpha, cos theta sin alpha minus cos alpha sin theta. I can further simplify this. That will give me Fm as cos beta times W1b minus Wc plus A cos alpha times W minus W1, this whole thing divided by A times sin of alpha minus theta. That makes sense because cos theta sin alpha minus cos alpha sin theta looks like cos of alpha minus cos theta sin alpha minus cos alpha sin theta looks like sin of alpha minus theta. We know this from trigonometric identities. Right. So, this is the expression for Fm, right. This you will get only after you do a substantial amount of simplification and careful bookkeeping, okay, something that you need to develop as you go along. In an NPTEL course like the one that you are now taking, the motivation for doing well in the course is left to the students like you. You need to put the fight, you need to keep the books, you need to learn how to do that. And I know that you are all self-motivated students, which is why you have come this far in the course. Invest a little bit more time and energy into keeping that discipline. Learn the art of bookkeeping and keeping a neat, disciplined set of variables that you are working with. For example, like the table that I developed, right? We developed this table like this. Okay. Now, let us proceed. We are not done yet. Because we only found Fm. We have to find Fj. There is more to go. Okay. Now, I can say sigma Fx equal to 0. Okay. This will mean Fmx minus, so that would mean Fmx is in the positive x direction and Fjx is in the negative x direction. Any other x component? No other x component. Fmx minus Fjx is 0. That is what it means. That would mean that Fjx is Fmx. And what is Fmx? We know what is Fmx. Fmx is Fm cos theta, is it not? So, Fjx is Fm cos theta. We are not done yet, we have to find Fjy. Okay. Sigma Fx equal to 0, right side going is considered positive. Sigma Fy, upward force, is considered positive. Whereas sigma Fy equal to 0, what are all the various forces? W is the ground reaction force that is acting in positive y direction. W1 is the weight of the leg that is acting downward. W minus W1 plus what else? Fmy is in positive y direction plus Fmy minus Fjy. Any other forces along the y direction? The answer is no. This whole thing is 0. So, that would give me Fjy as W plus Fmy minus W1. But I know Fmy. What is Fmy? Fmy is Fm sin theta. This is Fjy. Fmy is Fm times sin theta. Remember, this is Fm. This is Fm. Substitute for this value of Fm in your Fjx and Fjy equations. Then you will find Fjx and Fjy. Okay. What is Fj? Fj itself is square root of Fjx squared plus Fjy squared, is it not? This is the value of Fj, and the direction that it is acting along is some psi, which is tan inverse of Fjy by Fjx. Okay. This is the angle that Fj makes with the horizontal. Psi is the angle that angle. Okay. Fj psi, that angle. Okay. Simplify for this and you will find the value of Fjx and Fjy. In the exam, you will be given numerical values of small a, b, c, theta, alpha and beta and weights. You will be asked to find the numerical value of Fm and Fj. This would of course involve quite a bit of computation. So, unless you practice this with dedication and motivation, it will be very challenging for you to solve this in the exam. So, my request is take some time out and practice this problem and these types of problem from the same book or other books and get ready for the exam. Preparing for the exam is a semester long process. Remember this, preparing for the exam is a semester long process. It is not something that you do the day before the exam. Remember this. So, with this we come to the end of this video. In this video, we saw a simple numerical problem involving the hip, or rather a problem in the statics of the hip joint. It was a simple problem, but there were many variables involved and it required a lot of bookkeeping. I request you to practice this problem when you have the time and get ready for the exam. Thank you very much for your attention.